Hello, everyone, and welcome to Innovation Coffee, a show where we broadcast monthly talking about all of the amazing things that have been happening in and around the ARM developer ecosystem. My name is Robert Wolf.
And I'm Michael Hall.
And in this episode, we're going to be talking about a plethora of topics, including one, which is very exciting to me, Michael and Gabriel at OpenSauce in San Francisco last month. Another segment which covers a learning path brought to you by Pranay Bakra, where he talks about the Microsoft Sandbox and how to get started with the installation guide, as well as a learning path that is a very good one, actually, that was showcased on our Learning Paths website.
That's right. We're also going to be joined by Mark Mounier, who's going to be talking about confidential computing on ARM CPUs. And then Parina Varma is going to be on to talk about the Learning Path site that she and the solutions engineering team here at ARM helps to maintain.
Awesome. So we hope you'll stick around and check all these things out with us. Lots of exciting things happening. So I think let's just get this started. Mike, what do you say?
I think we should. Let's bring Gabe on here and talk about OpenSauce.
We had two of our very own evangelists, Michael Hall and Gabriel Peterson, present at the event of OpenSauce. Gabe, Mike, let's talk about this event. From what I remember last year, it was an amazing experience. We got to meet lots of creators, look at lots of really cool technology and the things that these people have been working on. What was your experience while being there this year?
That's right. This is our second year attending OpenSauce, and it is even bigger than the first year. It was easily like 3 times the size. They had to move to an entirely different venue. And there were just so many, really innovative creators building some mind-boggling things that they were showcasing there. And a lot of them were running on ARM CPUs, either Cortex-M or Cortex-A CPUs. And we actually, Gabe and I had a chance to go around and talk to some of those, do some interviews. So why don't we see some of that real quick?
Sure. Hey, hi, my name is Charlie Diaz, and I made a miniature replica of TARS from the movie Interstellar. I like the ability of the Raspberry Pi to be able to communicate over I2C to a servo driver. There are 9 servos inside of here, so we need to have, a lot of control.
So I'm Kazu Terashaki. I'm part of the SFHAB org group. So this is a San Francisco high altitude balloon group. So we are launching the balloon like this one. So this is a low altitude balloon, and we launch with this tracker. Tracker has a GPS, RP2040, and a ham radio, amateur radio transmitter.
Yeah, so I'm Jade Weinstein. I'm a clean tech engineer by day. I spend a lot of time thinking about edge controls and a lot of time thinking about my cat and how he's bored and idle. We're using an off-the-shelf 3D printer control board. So this is a 3D printer pulling a magnet around to move the mouse. The Pi we're using for computer vision primarily.
My name is Rodney. I'm an embedded engineer in the defense space, and I have this side project, Digital Fiber, which is a platform for electronic embroidery in textiles. But this is an ST-based array of infrared sensors, and when an object is detected, the corresponding LEDs activate. Moving on, we have machine embroidered LEDs onto a substrate that is controlled by a Bluetooth-enabled ST chip, and you're actually able to connect to this and play games like Pong or Tetris and that kind of thing.
So my name is Cedric Honnet. I'm working on miniaturizing electronics. This project is kind of asking the question, what if we can miniaturize so much that we can fit electronics inside fibers? And so the way I do is that I take the smallest ARM processor in the market, which is an STM32 C0D11 something.
Hi, so I'm Ryan Kunkel, and this is our wearable AI project. So basically, right here, this is a beanie with a Raspberry Pi and a Raspberry Pi camera inside of it. And that sends video to my computer. And then that video is sent to like an AI like GPT-4. Our demo is that when I point at something, it recognizes that I'm pointing at it, and then it will describe the scene, which is great for someone who's blind or something.
Hi, everybody. My name is Da, and then I'm one of the product managers for Libre Computer, and then we are using all ARM-based CPU cores. And then these are from a variety of vendors, from Allwinner to Amlogic to Rockchip to MediaTek. And then here we have a demo of a real-time application running on a non-real-time hardware. So these are WS2812 LEDs, and then we have generators running 3 separate panels on 3 separate channels. and they're able to stay in sync even though they're not running a real-time OS.
So they're all based, as Michael said, on Lego Mindstorms. So this has an ARM processor, a sort of microcontroller. I use these just for controlling the motors. There's an ARM A-class processor in the smartphone. This uses its camera to take a picture of the cube at the beginning. It calculates what the position of the colors are, samples the colors, then runs an algorithm on the smartphone to calculate an efficient way of solving it, transmits that via Bluetooth to the Lego Mindstorms, which then sequences the motors to actually solve it. So here we go. It's a 4x4 cube. So it's scanning with its camera, then immediately solved it and sent the solution via Bluetooth. Now it's physically solving it. It's difficult to see how it turns the faces because it's turning them from a turntable underneath. So it can rotate the bottom face of the cube or the bottom two layers. And then it tilts the cube to put the face that it needs to turn next, pointing downwards. The application on the smartphone uses some large lookup tables that had to be calculated. There are about 10,000 hours of CPU time required to calculate those, and I used some ARM servers on the cloud to do that.
All right, so those were some of my highlights there. Gabe, what was some of your highlights? I know you're really into a lot of more of this kind of, this creator environment. So what did you find the most interesting there?
So what I liked most about the event was everyone that we met that came by the booth. We had such a large diversity of disciplines of people coming to our booth and checking it out. And we had like mechanical and electrical engineers, software developers, artists of a variety of mediums, most of who incorporated tech into their art. So that was just great to see. I mean, it's one of those events that everyone is much more the type of people that we want to talk to. It's not so corporate. You're speaking to the developer because they want to speak to you and because they're passionate about development, and not so much because their company sent them. And so that's that environment is just so great to be in. Some of the other things that were cool, we saw it in the clips that were just shown, but the projects that people built, like I really liked that cat toy on the magnetic track that they're trying to actually bring to market, and then the TARS robot and the balloon with the RP 2040 in it. It's all of that was just so cool to see what people are doing with ARM technology. Yeah, I mean, what were your highlights of the event?
Well, I mean, we didn't come empty-handed to this event either. We had some pretty interesting demos that we were showing off on our booth. We had a mobile phone running a chatbot entirely on the phone, showing how application developers can incorporate this latest AI trend into their applications. We also, and this was our big draw for the booth, we had these Lego Mindstorm Rubik's Cube solving robots. So David Gilday, who works for ARM, built several of these robots, and one of them holds a world record for how fast it could solve them. So that was really cool. That was a big draw. We did get some really big names come over to see us, partly because of these. So we had Massimo from Arduino came by and hang out at our booth for a little bit. We even got to see Colin Furs, who we interviewed last year and got to hang out with. Stephanie also, who we interviewed last year, came by our booth again to say hi. And then we saw Jeff Geerling, who was out giving away these Raspberry Pi Picos out of a giant 3D printed Pez dispenser that he made specifically for that. So it was just a really, really fun event. We got to see some really cool tech, and just really nice to see the excitement in the hobbyist community for this technology.
And ARM's booth even made it into Jeff Geerling's video about that Pez dispenser. So that was cool to see. Slight correction. David Gilday's world record was for solving the largest Rubik's Cube at the time, which was, is it a 7x7 or a 9x9?
It was the 9x9 that was on display there.
That's right. So yeah, he had a record at one point for, I mean, that's just boggling to be able to solve a 9x9 in general, and to have a like we played around with the thing. The tolerances on just spinning that cube are so tight. Everything has to be lined up perfectly. So to be able to create a robot out of Legos that can do it is just, I mean, he's immensely talented with that kind of thing.
Yeah,
So what
they
do you
were
think,
fun
guys?
to watch. The event itself was amazing. I'm glad we got to go there and have a good time.
So what do you think, guys? You think you'll be going back next year?
Yeah, I've said that regardless of whether we have a booth or not, I'm going to be there next year. I'll pay my own way if I have to. So
Which is why what I ended up doing this year, because I wanted to go so bad. I mean, like, it's too bad I couldn't go for the second day, but I had a lot of fun while I was there as well, and got to hang out with a lot of really cool people, developers that were doing some cool things. So that's
yeah,
awesome.
so I saw that party that you went to. It's one of the, I can't remember whose video it was, but there was a creator that had a video of that party. So you somehow wandered your way into the content creators party and not the VIP party that we were all invited to. So
I
you
think the
got the
content creators
extra.
party was more VIP than the VIP party, it seems.
Yeah, no, that's the whole point. Yeah, you lucked your way into like a really exclusive party. So
Yeah, it was pretty fun. Lots of cool stuff. Yeah, I mean, I got to hang out with pretty much all the folks that you were saying, but over hors d'oeuvres and drinks. So it was definitely a fun experience. But yeah,
that.
awesome, guys. Well, I mean, I think that covers open source. So thank you so much for sharing your experience, and those interviews that you had were really great. If you want to see more of those interviews or the full length of all of these interviews, they will be available on YouTube. You can go check those out in the description below and get access to every single one of them. And tell us what you think by commenting on them and or sharing them with your friends. So lots of cool stuff happening. Now, Michael, I believe we should move on to the next segment. What do you think?
Yeah, I think so. I had the opportunity to talk to Pranay and record this session with him a little while ago, so let's check it out. Pranay, welcome to Innovation Coffee. How are you doing?
I'm doing good. I'm ready with my coffee. So thanks for inviting me.
Perfect. Now, you and I were in Seattle back in May for Microsoft Build, and one of the big topics there was CI/CD on Windows on ARM. And you've got actually a learning path now that focuses on one way to do that using Windows on a self-hosted GitHub runner, right?
Yes.
So why don't you take us through what the learning path covers and show us how to do this?
Sure. Yeah. Just seems like yesterday we were there a
Yes.
month ago. It's already been a month. All right. So I'm going to talk about two parts. One is going to be the install guide that we wrote for Windows Sandbox. What Windows Sandbox is, how you can enable it on your laptop, on your Windows on ARM laptop. And then I'll talk about the learning path of how to configure Windows Sandbox as a self-hosted GitHub Actions runner, and then run your CI/CD pipelines and build and push your code in the repository, and then actually see that application getting deployed. For the part of this demo, the application that we are using is a .NET 8 based WPF application running natively on Windows and ARM. So with that, let me go to the install guide. I'm sorry, one part which I missed is that in the end, after we go through the learning path, we'll also see the demo of how exactly that learning path gets deployed, how you can follow those steps, and then what the end result looks like. So let's go to the install guide first. So a little bit of context about what Windows Sandbox is. So it's a lightweight desktop environment from Microsoft, which you can leverage to safely run and test your applications or a piece of software that you're writing yourself. Let's say, for example, you downloaded a binary and you want to test it out in your code library, but you cannot use it specifically, maybe for any different number of reasons, some security practices. There could be n number of things which you cannot directly upload it to your company provider's pipelines. So what you can do is you can launch Windows Sandbox, which is essentially a lightweight desktop environment, and it's completely isolated from your machine. So if you are running a Windows on ARM laptop or a Windows dev kit, you can launch it, and it launches within seconds. Like I said, it's isolated at a kernel level, and you can use it um, to deploy any piece of software that you'd like. Any dependencies that you might want to install can be installed in that device as well, in Windows Sandbox. So the first thing you'll need to do is to enable virtualization in a Windows on ARM device. You need to use Windows 11 to enable it. And these are just the steps to enable the virtualization. Um, and you can follow along the steps. You can check if uh, virtualization is enabled in the firmware, and if there is Hyper-V requirements have been satisfied, and then you just install Windows Sandbox. So when I say install, essentially you just enable it by using um, the turn Windows features on or off panel, and you just enable it here, which is this particular piece. And then once you hit OK, you just restart your computer. And then once you come back on your physical Windows on ARM laptop or Windows Dev Kit, you should be good to go. You can go in the run dialog and just type Windows Sandbox, and it will be there. So with that in context, now let me move over that. Okay, now we've established that, okay, I can run Windows Sandbox. I can run it within seconds. I know how to enable it, but how do I use it and what do I do with it? So for that, let's go to a learning path on what you can do. So in this learning path, what we are doing essentially is we are configuring Windows Sandbox as a self-hosted GitHub Actions runner. So like I said in the beginning, if you want to run a piece of code for your application and you are not too sure how it will fit well, or you are not too sure, we all of us do sandbox type coding and building, right? We try to develop code first on our laptop first, and then we push into the pipelines. So this is part of that, where you're using your CI/CD pipeline, which you have for yourself, and you're using it as a self-hosted GitHub Actions runner. So on GitHub Actions, you can deploy Windows on ARM-based runners that you can host on your laptop, in the cloud, anywhere else. But for the purpose of this, we are using Windows Sandbox, again, because running a little bit of software. So in this learning path, we are also talking about the application we're using is a .NET 8 WPF-based application that we'll be using. The prerequisites are, again, like I said, Windows on ARM computer, such as a dev kit or a Lenovo ThinkPad, and you'll need a GitHub account for sure. Let's go next. So in this, we use the application that I'm using here is a traveling salesman application. Basically, it solves a algorithmic problem of traveling salesman, and how the optimal route of that salesman can be found. And you can use the implementation of it is WPF based, Windows Presentation Foundation. And so what we'll do is, in this learning path, is we prepare a GitHub repository. We talk about you clone this GitHub repo, and I'll show it as a demo as well. Once you clone it, you configure the Windows Sandbox as a self-hosted runner. Once you use it as Windows and ARM runner, after configuring, these are just simple steps of installing a Windows and ARM runner. You deploy it, and once it's done, it's connected, it will be ready as listening for jobs. So all of these commands you'll run inside a Windows Sandbox, the one that we just launched after rebooting our computer, after following the install guide. So once we have that in place, our Windows Sandbox runner should be here available. ready and listening to jobs. So the next step we're going to do is we'll build that CI/CD pipeline. So again, when you clone the repo in the previous step, you'll get all of these YAML files. So essentially, what this YAML file is it's using the Windows Sandbox as a self-hosted runner. So you'll use this particular line. You can keep it workflow dispatch or push, so that anytime you push it to the repo, it's going to run that CI/CD workflow. It's a typical CI/CD workflow pipeline. The one change you'll need to make is self-hosted. It's part of the GitHub repo, but I just wanted to highlight it here. Self-host runs on self-hosted means that you're running it yourself. Then what it's doing, it's checking out the .NET code, and again, these are all the steps that I'll show in the video that I recorded, and the architecture of it as well. But I'm just going through it once. It's doing a .NET restore. It's using .NET version 8.0. Remember, .NET, I think 5 onwards is supported. I think 6, 7, 8, and maybe 9 is supported Windows on ARM, and you can deploy your .NET-based application. That's what we are doing here today. And then you run the pipeline, right? So it's a typical workflow. You run the pipeline, it triggers the pipeline, and you can see your application getting deployed. So now we will go, this is the application, basically. So now, since we went to the learning path, now we will talk about the demo and how this learning path gets implemented, or what it looks like when you go through step by step. So I'm going to switch it over. I'm going to make it a full screen. So this is showing the architecture of the CI/CD pipeline. You can use a Windows and ARM developer VM. Like I mentioned, you submit a GitHub push to the repository. You deploy your code in a GitHub Actions self-hosted runner. When you push it, it's going to push all these changes. It's going to start to build your application, and it's going to deploy it either on the runner, where you can check if it's running perfectly fine. When you run through your unit tests and everything, you can either push it to the cloud or any of your deployment targets that you have. Okay, so here, what I'm doing here is essentially a C# file which is launching going to launch the Windows Sandbox using the token from my self-hosted runner. So I'll go to my repo. This is the repo that I created, and I'll take out the token for registering the runner. So what I'm doing here, as we saw in the learning path, I'm going to take the token to install GitHub Actions runner on my Windows Sandbox. So I'm going to copy that token, and I'm going to give it to the script that I'm running. So again, this is just a little bit automated, but you can do it manually. You can just use it as is. It's just automating these steps. Then here, I'm going to enter my repository, which is this repository's URL, and I'm going to pass it to that PowerShell script. So here, and then I enter. So as soon as I hit enter, you'll see Windows Sandbox getting launched. So just see how quickly it gets launched. So all these steps are enabled, and it just takes seconds to launch. And there you go. You have like a development environment by itself. Now, all the steps that I talked about in the learning path, these are all happening now simultaneously, and you'll see a Windows PowerShell dialog box open, and it's going to download the Windows on ARM self-hosted GitHub runner binaries, and it's going to attach it to our GitHub repository. So this is downloading. And now, while that's getting downloaded, let's see how the application is going to look like. This is how the application is going to look like once it gets deployed. So right now I'm running it on my laptop. This is not running on the Windows Sandbox. I'm just showing you how the application is going to look like once we deploy it on the Windows Sandbox. Okay, so now it's downloaded, and once it's here, it's already downloaded and it's trying to register the run-up. And as you can see, I think it's already registered and it's now ready and listening for jobs. So now let's go back to our GitHub repo and see if we see the Windows Sandbox in there. Let's go to the runners, and there you have it. Right. So this is what we saw as part of the learning path, and it shows up right on cue. Now, what I'm going to do is I'm going to make a change or a push to my repository. So like you see, it's listening for jobs. Let's go to the repo, and when I built the repo, I forgot to add a README file, which is not a sane thing to do. You should always have a README file for your GitHub Actions or for your GitHub repo. So all I'm going to do is add a README file to it, and then I'm going to commit those changes. So what it's going to do, it's going to trigger a push, and it's going to trigger the build process of it, and then the runner should be able to pick it up. So now let's commit changes. All right. So now that is committed, let's go back. It's already running the job. Build is the job that I have as part of the repo. And now let's go back to see how it's running it. So I'm going to go back to the GitHub Actions or the YAML file, and you'll see that it's already triggered a job. Create README. Let's see what's happening inside. So right now it's installing the dependencies. Again, since Windows Sandbox is a fresh copy, fresh install every time, the moment you close that button, it's all gone. It's exists. That's why you'll see all these dependencies getting installed. So, but once you're done doing it, you don't have to reinstall it every time. So all the dependencies are in that self-contained environment. They stay on there unless you close that window for the Windows Sandbox. So you'll see this is our project path. This is where our eventually build executable is going to reside. And then it's checking out the .NET code, just like what we saw in the learning path. And then it's going to .NET restore, build, and publish. And it's going to, if you look at here, we are going to publish a native Windows ARM64 binary, which is going to run on this self-hosted runner. Now, let's see where our build has gone so far. Has it finished? No, it's not. Let's see. So it's been running. Again, it's taking a while because it's installing everything from the scratch. It's a fresh copy. Once you do it one time, then it's not going to take this long. Okay, so it's still running. So here, as you see, so this build finished. This build finished, as you can see here. Now let's see, look at the Windows Sandbox. Yes, it says that the job is completed. Now let's go back, copy the path where this final build or our application's executable is going to be published. And then let's see if it got deployed on a .NET 8 based application on a Windows on ARM Sandbox device. So let's go to the path in Windows Sandbox. I'm just going to copy it over. Okay, Windows ARM64. Let's go back to the, here we go, publish folder. Yeah. And then too many DLLs, you can optimize the workflows. You can have like a self-contained single one binary. But yeah, this is the application. And then you double click it and should open up. Yeah, there you go. And you just start and you get the path for the application and how the traveling salesman problem is going to get solved. Okay, so that's what the demo is for the learning path and for the install guide. Hope you guys like it. Thank you so much.
All right. Thank you so much, Pranay, for coming on and for showing us this. This is an excellent resource for any developer who's working on Windows desktops. If you want to try this out yourself, you can find that learning path at the link below. Once again, Pranay, thank you for coming on.
Thank you.
Did you know about the ARM Developer Program? With thousands of members and hundreds of subject matter experts, ARM developers now have access to a wealth of resources and interactive experiences tailored to facilitate your engagement with industry professionals and your fellow peers. Share ideas, projects, trends, ask questions, and get support by interacting on one or more of our ARM Developer Program channels like Twitter, Discord, Reddit, or our very own Developer Hub. You can also participate in weekly live streams and office hours, watch and interact with the ARM Developer Evangelist team on YouTube while we interview some of the biggest leaders in tech, or hang out with us in a more intimate setting on Discord for Q&A sessions, show and tell, and much more. To find out more about the developer program, all you have to do is visit arm.com/developer program. And if you'd like to become a member, simply sign up and become part of this vibrant and growing community. Expand your skills, grow your network, and shape your future built on ARM. We'll see you there.
I did know that. And in fact, you can find myself, Gabe, and Robert all as part of the ARM Developer Program. So go check that out, join us, and let's have some fun together. Now, Robert, I understand that you have an interview with Mark that you have.
Yeah, so Mark, we have on the call here, and he'll be talking to us about confidential computing and the confidential compute architecture, a series that we're actually going to be releasing later this month. He would like to provide a little teaser to us about what this series is going to be about. So, Mark, why don't you just take it away? Tell us what we're going to be learning in this series coming up.
Thanks, Robert. Hi, everyone. My name is Mark Meunier. I'm a director of ecosystem development in the infrastructure line of business at ARM. This month, we are kicking off a tech series to bring you the latest in innovation, but more importantly, ensuring that you have the tools to take advantage of this new technology. In this series, we will explore confidential computing on ARM, the technology that enables you to retain ownership and control of your data, application, and models while running on third-party infrastructure. We'll start off with an overview of the changes to the hardware architecture. We'll explore the impact to the firmware and operating system and explain the crucial role of attestation. We'll also touch on some of the use cases that are unlocked with confidential computing. I will then pass it on to Purina Verma, a principal solution architect here at ARM, to explain how you, as a developer, can start using confidential computing with a fixed virtual platform. This will ensure that you hit the ground running when a partner silicon hits the market. Stay tuned, you won't want to miss this one. Robert will provide more information to ensure you get access as soon as it's available. Oh, and if you're already familiar with confidential computing, scan this QR code and provide us some feedback. We'll look at how we can incorporate that information back into the series. Thanks for having me on the show.
Yeah, thanks, Mark, for being here. We really appreciate you joining us on the show. I look forward to getting those videos out with you later on this month. It's going to be a great series, just like Mark kind of summarized there. If you're interested in confidential compute, make sure you scan that QR code. Make sure you tell us what you're interested in learning, and if you don't know just yet, then you can find out by watching the series later this month.
All right, now let's go over to Purina Varma from our solutions engineering team and discover what's new in our Learning Paths site.
Thanks, Michael. Hi, everyone. My name is Purina Verma, and I work at ARM as a principal solutions architect. I'm here to introduce ARM Learning Paths. A little over a year ago, we at ARM created a new way to share how-to content for software developers on learn.arm.com. Learning Paths provide a long-form written how-to content for software development on ARM. It's a community-based project, and it provides a place for everyone to share their steps for deploying a variety of software and a wide range of ARM-based hardware. You can easily create and contribute using GitHub. You can click on the Create button on the front page of learn.arm.com and find out how you can get started and create your own learning path today. Over the course of the past year, we've had close to 300 learning paths and install guides, and excellent engagement from the community and feedback that we're continuously looking to grow and improve. As part of this segment, every month, I'll join and introduce some of the hottest learning paths that we've recently published. If you have any questions or feedback for us on ARM learning paths, please reach out to any of our developer evangelists or myself on Discord. You can find the link for Discord in the description below. We really look forward to hearing from you and receiving your contributions on learn.arm.com.
Did you know about ARM's Developer Hub? Whether you are just getting started on ARM or looking for resources to help you create top-performing software solutions, the ARM Developer Hub has everything you need to start building better software and rich experiences for billions of devices. Explore tutorials, code examples, and install guides by tapping into our learning paths. View on-demand technical videos from ARM's vast ecosystem of developers. Stay up to date on developer-focused events, both in-person and virtual. Find your way to our Discord server for real-time engagement with ARM experts and your fellow peers. Get support and the latest developer-centric news. Seek training and learn more about the ARM architecture. Explore our vast library of technical documentation and gain access to a wide range of downloadable tools and software, and so much more. Visit arm.com/developer-hub to begin your journey with us on ARM. We'll see you there. Gosh, that Robert guy, always asking us questions whether we know or not, whether we know what's going on around this developer ecosystem with ARM. But yeah, no, the Developer Hub stuff sounds pretty interesting, I have to say. And if you haven't already gone to the Developer Hub, just go to arm.com/developer-hub and explore what they got going on over there. It's lots of interesting content.
Well, Robert, this has been a great episode, I think. I'm really enjoying the new format. We can really squeeze a lot more information and technical insights into these episodes now. I hope everybody watching it likes it as well. If you do, let us know in the comments.
Awesome. Yeah, thank you very much. And we'll see you next month for the August Innovation Coffee here, brought to you by ARM.